Okay guys, in my previous video I have told you how to solve the fault currents, positive, negative and zero currents. I mean part A of this question. Now I will move to part B. So it's asking that at bus in the point B it asks for the sequence components of current at bus 1 connected to the generator. So I have draw a rough circuit for my own understanding. In the question they are asking for this Ig, D, I and zero current. So we have to find the generator current if there is a fault at bus number 3 that we already discussed in part number 1. So in this case guys, always remember there's a formula for voltage. Positive sequence is 1 plus I into reactance. Reactance is basically the impedance, but in this case there is no resistance, so that's why we put X. For negative sequence is only reactance minus current. And for zero sequence is also the same, reactance minus current. In this case, if we have to find the current, we must know the voltages of bus 1. So in this case all these voltages are for bus 1, and consequently this current is the positive D1 I1 01, or in the other words you can say IG and IG, as you wish, you can name anything. For the reactance you can see this is the positive reactance 0.3, so it's Xg for generator reactance. It must be noted that for positive and negative it's 0.3, but for zero it's different. If you see in the figure it's 0.2. So guys, here you have to note that this voltage and this voltage is basically the post voltages. And we have to find these values, because basically we have to find I and I. We have to find these values. To find these values, this is known, reactances are known, but these voltages are not known because these are the post voltages. So for this one we know that V1T is equal to this, the post, V1D pre-fault plus del V1D. Similarly, V1I is equal to del V1I. There will be no any post fault. This must be remembered. And sorry, V10 is equal to del V0. I have 10. Here, this is the post fault. If we find the post fault voltage, we can easily find our required current components for the generator. And for this post fault, we know these formulas. For the pre-fault, it's already given in the question. The value of pre-fault is 1 volt. But for delta V, we don't know. So in this case, we have to find the delta V. So go to the next page. Now we can write it here. So del V1D is equal to Z into I. Here, this is our D and I component. This will be minus. Now we have the matrix 4 cross 4 in our given question. So if you see, the fault already happens at bus number 3 and we are finding the value at bus number 1. So this matrix will be 3 cross 1. Okay, because 3 comes first, because the fault already happens here and we are finding for 1. So 1 will be at the end. If the fault happens here 1 and we are finding at 3, then it will be 1 3. This must be noted. And minus sign. So we have to find the value from the given question. So in the given, the third row, first column, we have 0.15 iota. Now minus id as we have find before, this one, it is 0.597. So minus 0.5970 iota. By using the calculator, so this will be 0.0896. It's not iota. So the second thing we have to find is del Vi. The formula will be exactly same. Three cross one, same the values, because you can see in the question that for the positive and the negative sequence, the matrix is same, so value will be exactly same. And for the zero sequence, we have different Z matrix given in the question. Three cross one. 3 cross 1 is 0. so the whole value will be 0. uh, so guys, we have found all the values, missing values here, so I will use the different color for your understanding. As you can see, this is v1i and this is v10, and the positive value is different in this case because it is added by the pre-fault value, that is 1, only for the positive case. So v1d will be 1 plus minus 0.0896. It will be 0.9104 by using the calculator. So guys, we have calculated all the required values that is necessary to find the generator current. So we will put all the values here, and we accordingly find the positive sequence, negative sequence and zero sequence currents for the generator in this case. Guys, here you can see that by putting the values I get the positive generator current as this value, negative current as this value, and zero sequence is 0 because the voltage we get is 0. This is 0. One thing I was taking mistake is this formula. This was a minus sign. Before it, I did not put this minus sign. This was there, but this was I did not put, so there is a minus sign here. So guys, these are our currents, but as you know, there is a transformer after the bus bar 1 here, so we have to apply the phase shift on all these three currents. Phase shift, phase shifting formula, as I believe you all know. For example, if you want to put the phase shift on this one, then it will be after phase shifting will be IGD exponent का 30 by 180 pi iota, and it will be like IG into cos theta j sin theta. So theta in this case is 30 over 180 multiplied by pi. This is the phase shift of transformer. Okay, when you put this value in here and Ig this one here, you will get the phase shifted value at the generator, that is 0.1493 minus 0.2585 J. So after calculation, the positive is here, and for the negative you have to put the minus theta, cos minus theta plus j sin minus theta, so you will get minus sign differ in the magnitudes. For the zero sequence, it's already 0. You can see here zero sequence is already 0. So these are our two values. I hope this understand. Thank you.